Good morning. LU factorization. So consider this matrix product. Now here I'm sticking with a 4x4, but the general concept is the same. This is what's known as an LU factorization. Now this is the product of a lower triangular matrix and an upper triangular matrix. So the goal in an LU factorization is to find the L and the U. So each of these stars, any real number. Each of those four squares, or in this case, or in a general case, along the main diagonal of the upper triangular, non-zero, real numbers. They don't have to be ones. Stars are Now, using the LU factorization, we can use this to solve systems of equations, specifically square systems. So consider the system AX equals B. If A equals L times U, then we'll have UX is equal to Y, where LY is equal to B. All right. So the method of solving a system using LU, first you want to get it into LU form. You write your coefficient matrix in LU form. Solve Ly equals B for Y. Then substitute that Y in and solve UX equals Y for X. And so let's find an LU factorization for A. And the LU factorization is not necessarily unique. There are several algorithms to find an LU decomposition. The simplest is the algorithm that I'll go over now. Start with your matrix. So perform the row operations on it as if you were trying to row reduce it. And here you definitely want to keep track of what you're doing. And so 6 minus 4 is 2. And 6 minus 2 is 4. So, except I did the wrong thing, sorry. Should be negative 3 minus 2 is negative 5. Negative 10 plus 7, and then 5 plus 1. Except here, do not make that 2 a 1. Leave it as a 2. Five halves, row 2 plus row 3 should zero out that negative 5. Zero. Negative 15 halves plus 6.
Negative 3 halves.
There's your U. No, I'm actually not going to copy that. The L. We want it to be lower triangular. We set it up this way. Right, and the idea is we want to find each of those stars. That's not too difficult to do. Let's look at box right now. That entry right there. That is the what? 2-1 entry? Go back to the process of finding U. How did you zero out that 2-1 entry? What did you multiply by? So the 2-1 entry in L is negative 2. And you do the same thing for each of the stars. 3-1 entry, what did you multiply by to zero it out?
1.
So the L entry there is negative +1. So -1. And then that was a 5/2. So -5/2, there's your L. And I'll rewrite U. And you can confirm it. Just do L times U and make sure you get A. Which you will. That's the algorithm. So the general idea is you want to put the matrix A into upper triangular form by only using the type 3-row operation. And you don't want to switch rows, and you don't want to switch rows, and you don't want to multiply a row by a constant. Again, this isn't the only way. So those are not the only 2 triangular matrices where A would equal L times U.
This is just the easiest.
Yeah. This is typically the starting method. And then once you get more comfortable with it, you get introduced to more complicated methods. And chances are, if you have your calculator find LU for you, probably won't get this. Probably get something else. So let's start. -2 row 1 plus row 2, and then 5 row 1 plus row 3. Okay, that's our first desired column. Uh-oh. -8 plus 8. Then 20 minus 9. 6 plus 1. Negative 15 plus 7. No, negative 15 plus 7, negative 8. You just got a 0 in the main diagonal. It's a problem.
I'll stop phrase 2 and 3.
There's no LU factorization here. So there is an algorithm for swapping rows. You do something with the L. I forget what it is because I never use it. But it's still going to ultimately wind up being you can't do an LU factorization because of that 0. I'm actually curious what the calculator would say. Menu 7. Where was it? Advanced, yeah. LU decomposition. All right, so advanced LU decomposition. How does that work then? I thought that was going to give me parentheses. So is it just this then? Enter the matrix. So I'm going to start with A, which is what we did previously. Too few arguments. So do I need parentheses then? It just didn't give it to me. No. Okay. Shows how often I use the calculator to do LU. Okay. I think I got it. Don't need this. I need the matrix. Lower, upper term. Okay, so now you give me that. Oh, right, okay. That's not right. Then I have to enter lower, so there's the lower, according to the calculator. And there's the upper, according to the calculator. Yeah, so like I said, not what we got. Very unlikely that you're going to get what we got.
So the calculator is wrong.
No, it's not unique. LU is not unique. So the calculator is using a different algorithm. And I don't even know what Mathematica would give you. Probably not the same as the calculator. Be interested. So it does give one.
Can you flip the rows that way?
Because the source I got this from says the LU is not possible. I know you can flip the rows. So let's see. I have a different algorithm. Ah, yes, they're doing a really nasty algorithm. That is one way of doing it. Oh dear. That's how they're doing it too. Oh my god. Okay, so that's what I'll do. Be interesting to see if that's what I get here. Okay. So they are doing the most obvious method, which is definitely not the best. So we'll just get rid of U. So using that algorithm, that's not possible. I need to switch back. Oh. Thank you, kids. What variables do I want to use? Oh no, that's 2, 2. Not gonna lie, I've never seen this method, but it is the most obvious. And then solve. Yeah, I'm with you. This is hideous.
It seems like an excessive amount of.
It is. But unfortunately, my algorithm doesn't work. I have to go back through my texts. See if there's a more efficient algorithm in one of them. Because this is just awful. What's the first row going to be? Should just be the first row, right? U11, U12, U13. If you do that matrix product. Because these are just zeros, so they're going to cancel everything out. At least that's nice. I'll worry about everything else later. My next entry. Well, that's kind of nice. Oops. That would just be that, right? When you do the matrix product, L21 times U11. And then it's just plus 0 plus 0. And next one would be similar. L31 times U11 plus 0 plus 0. You know what? I'm not going to set up the matrix. I'm going to go ahead and just write these as equations right now. Because that's ultimately what we're going to have to do anyway. 1, 2, negative 5. That's U12 is going to equal 4. Now that next entry, L21 U12 plus U22. Equals 8. This is not fun. L31 U12 and then L32 U22. And that has to equal negative 9. U13 equals negative 3. This is going to be hideous. L21 U13 plus U23. L32, right? That has to equal what? 1? And then L31U13 plus L32U23 plus L33 has to equal, or U33 has to equal 7. And then you get to solve that system. Looks like U11 is going to be 1. How do I want to set it up? Should I just set up my two matrices? Yeah, something like that. So U11 has to be 1, which means L21 has to be 2.
Yeah.
And L31 would have to be okay, that wasn't too terrible, I guess. U12 has to be 4. Okay, this is where it's going to get hideous. And U13 has to be -3. Oh yeah, we know L21, don't we? And so that's 2 times 4. Yep, U22 has to be and U22 has to be 0.
Now, that's how you got this stuff. And the famous thing that's about the other, usually 7.
So L21 is 2, U12 is 4, which is 8. 8 plus 0 is 8, right? That would have to be 0. I don't like this method. All right, 1, 4, -3, 2, 8, 1, -5, -9, 7. Oh, that's all right. I'll just keep going and see what I get. So he said L21 is 2, U1, so that's -6. So L32 would have to be 7.
Professor, for 2 by 3, would it be L21 U13 plus L32, or would it be plus U23?
For which one?
The spot 2 by 3.
This one?
Yeah. Would it be plus L32 or plus U23?
L21. Oh, that should be U12. Yeah, I looked at the wrong one, didn't I? Plus U22.
I got L21 times U13 plus U23.
Oh, that should be. So I'm looking at the 2. Oh, the 2-3 entry. This one here. No, 2-3 entry here, right? Yeah. I'm confusing myself. Yeah, so L21 U13 plus L32 U22. Right, because it's going to be second row, third column.
Yeah. For a second row, third column.
It should be just U23.
Yeah.
Right? Yeah. And that equaled, what did I say, 1? Yeah, 1. That's going to change that value. You said L21 is 2. That's -6 plus U23. Which would be this here. That's 7, right? That one's 7. I still don't have L32, but I do have U22 now. All right. So that's what, -5. That's -20.
0.
Plus 0. Uh-oh. Yeah, so see, that's not going to work. So that's that. L21 U11, right? L21 U11. Just make sure I did the rest of the products correctly. Yes. Yeah, U12. L22 U12. No, L21 U12 plus U22 has to equal 8. Okay, you know, I'm not wasting any time on that. I'm going to re-examine that one and see what the calculator is doing versus the two methods. Because that would still give you then not possible, right? Because you get -20 equals -9. And I entered it right in the calculator. No idea what the calculator's doing. Good news is nothing like that occurs on the test or quiz, so I know that. So I'll re-examine that one. I'll look at my source. Start with the coefficient matrix. Write it in terms of LU. This one works. I get that. 2, 1. Then you should get what? -1, -4 to finish off the second column. 1, 5 finishes off the third column. Yes. And 1, 1, 9. No. Should be -4.
It's positive. It's positive. Oh, negative. Never mind.
Yeah, I did the same thing. That's a -1 there.
Yeah.
There's U. Right, and then of course L is set up, 1 on the diagonal, 0's above, and then it's going to be in the first column 2, -3. And the second column is +4 to finish it off. And again, I'm just going to rewrite U. We have to solve this equation for Y. 2 ways to do it, right? You could do Y equals L inverse times B. Of course, the problem with that is you have to find what L inverse is. Right. Or set it up. And what was B? 1, 1, 1. And then solve. This is a system, right? So this will be forward substitution. You get y1 equals 1. That's nice. Two y1 plus y2 has to equal 1. Negative 3y1 plus 4y2 plus y3 equals 1. I'm just going to write it up here. 1. 2 plus what is 1? Negative 1. Negative 3 minus 4 is negative 7. Plus what is 1? Okay, why are you giving me a symbol? I don't want that there. Plus 8. There's your y. Why did I duplicate? Right, because now you need to solve ux equals y for x. And this would require then the backward substitution of Gaussian elimination. We know x3 has to be 8. 8 minus what is negative 1? Nine. So negative 9. And then it's what? 8 minus 18 is, should be negative. Right, 8 minus 9 is negative 1, but negative x2.
It's positive 8.
Right, so negative what plus 8 is negative 1? That's what this is asking.
Yeah, so it would be positive 9, which would become negative because it's negative x2. So x2 would become 9.
Oh, you're right. Why do I have a negative? I didn't have a negative there, did I? I looked at the wrong one. No, you're right. Yeah, positive 9. That makes this easier. 8 plus 18, 26. plus what is 1? And there's the solution.
Is there like a real life example where I would use LU-factorization?
That I'm aware of now. If I remember correctly, and it's been a while since I've actually looked at LU, I think this is mostly helpful in computer algorithms. Solving square systems using LU is more efficient algorithmically than RREF.
It seems like a lot more work than yeah.
Because we're doing it by hand. If you actually look at the coding and how much time it takes for a computer to calculate, I think, if I remember correctly, this is more efficient. I don't know how any of that works. I'm not a comp sci person. But I think that's what it was, and that's why they go over it. Again, I've never used it, but I'm not comp sci. That was physics, so this was definitely not efficient for us.
I don't know if I completed this question, but I was just looking at the system. So this solves for the system, right?
Yep, that's the solution to the system.
Where's the
I used x1, x2, x3 instead of x, y, z, same thing. Just replacing. So it'd be x is negative 25, y is 9, and z is 8. So yeah, Nisa, I'll be happy when we're done with LU because this is just not fun for me. No. Again, it's not bad if you can code it, but doing it by hand is just a nightmare.
So is a lot of linear algebra just theory-based stuff?
Yes. Well, so like I said, linear algebra is split into two things. Matrices, so matrix theory, which is very useful in comp sci, right? Because you use arrays a lot in comp sci, and linear spaces, which is very abstract and theory-based. Linear spaces does have some physical applications. Like I know it has to be studied for engineers. What they are, I don't know because I never used them in physics. Unless they argue, oh, well, it helps you understand vectors better. Which could be, I have no idea. Right. But I also know matrices are useful in general relativity when you have to do tensors.
Does data science use linear algebra?
Yes. So, because I believe in data science, you're also going to have to take some upper level stat.
Yeah.
Anytime you do multivariate data analysis, it's essentially matrices. So you'd be using matrices in that when you take a stat that's multivariate. Oh boy. Zero out the first column. Oops, not row 2, row 3. All right, let me get what? 2 plus 1 is 3. Negative 2 and 0. 3 and 2. Negative 6 minus 3. That's nice. 6 and 4. Negative 9 and 1. Negative 4 and 1. 4 and 1. Negative 6 and negative 2.
It might be a dumb question, but does it matter which the order you write the matrix operations, you know, because we apply at the same time?
In terms of how I'm writing them here?
Yeah.
No, doesn't matter. I just write it in the order in which I'm going to do it, starting at the bottom, working my way up, but it doesn't matter how you do it. Negative 3 row 2 plus row 3 should zero that out, right? And then row 2 plus row 4.
Shouldn't it be positive?
You're right. Negative 2, 3 there. Negative 2, 5 there. All right, let's finish this off. Negative 6 and 10. 4? Yes. 15 minus 8, 7. And that'll be negative 2 and 5. 5 minus 8. That, right? Now comes the fun step. What happens if I do this? Yes, that works. Just don't use my mouse. What times 4 gives you 3? Or negative 3, rather.
Negative 3.
So negative 3/4 row 3 plus row 4. This will get us to our upper triangular. Negative 21/4 minus 3. What was it? Yeah. There's you. Thankfully, we're not going to have to work with that negative 33/4 anymore. And then L, just go in reverse order. -132 for column 1. -3, 1, or negative, sorry, what's going on? Yeah, -3, -1. Yep. And finally, 3/4 to finish off column 3. And there's L. This might be a good time. To look up how to do this in Wolfram. Let's see if that does it. Nothing like that. So what are you doing? Okay, now Wolfram's too confusing. So I'm going to do it using the calculator. Instead of doing the LU by hand, I'll plug into a calculator and use what that gives, and then solve the system that way. And really hope this doesn't give me something hideous like it did my hand. So coefficient matrix. First row 2, 2, 1, 0, right? Second row 3, 0, negative 1, 1. Third row 0, 1, 0, 5. Fourth row negative 1, 1, 0, 0. Let's type that in. 0, 1, 0, 5. It should stay as yep, lower, upper. That's not too terrible compared to what I got. So there's our L. A third, a half, 1, 0, 0, a half. Switch back to here real quick. That's what we have to solve, right? Y1 has to be 10. Y2 10/3 plus what is negative 11? All right, so negative 11 minus 10/3. Negative 43 over 3. Oh, gosh. Oh, this will be fun. 5. Oh, wait, no, that's not right. My one was 10. It's 20 thirds, right? What was I saying? 10 thirds. So negative 11 minus 20 thirds. That's even worse. It's negative, what, 53 thirds? So then we get 5 plus 10 thirds, 25 thirds, minus, winds up being plus 53 over 6. I am not doing this in my head. No, thank you. Five plus 10 over 3 minus half times. This is hideous. And then it'd be what? 14 minus a half y2. Minus 5/7 times y3. This is just awful. I'm going to leave that there for now because now I need upper. That's the upper. Which is really hideous. When you solve that system, you should get x1 is -4, x2 is 10, x3 is -2, and x4 is -1. Just verify that. And I'll never use this method again. Because this method is the worst.
So Mathematica, is there like a method for LU?
Yeah, it's really convoluted. Which is why I didn't use it.
Who was x1 again?
x1? Yeah. -4. So you should have one new assignment up, the second discussion assignment. Initial posts are due Thursday.
We don't need to sign up, right?
No.
Oh yeah, I need to talk about Canvas. When I did the quiz and looking at each one of the questions, it says it checks it off as if I answered it when I haven't even put anything in yet.